a cyclic schedule or a cyclic executive. The stored table that gives the pre-computed cyclic schedule has F entries, where capital F is the number of frames per major cycle. Each entry lists the names of the job slices that are scheduled to execute in frame K. In figure 5.7, the entry is denoted by N of K and is called a scheduling block or simply a block. The current block refers to the list of periodic job slices that are scheduled in the current frame on a CPU. So this is a pseudo code which shows. So the next topic, it is improving the average response time of periodic jobs. There is no advantage to completing a job with a hard deadline early. On the other hand, the sooner a periodic job completes, the more responsive the system is. So one way to improve the average response time of periodic jobs, it is by slack stealing. Slack, it is referred to the time within a frame during which no job is getting executed. So what we will be doing is, one way we will be improving the average response time of a periodic job, how it is means by making use of this slack period. So what we will do is, we will calculate first of all how much slack time it is present in each frame, and we will store it in the form of a table, like entries in a table. And what we will be doing is, whenever any periodic job comes, by using each entry in this slack table, where each entry it is for one frame, we will be making use of that slack time in the frame, and we will be executing that periodic job by using this slack time. So this diagram shows how to execute the periodic jobs by using slack stealing. Average response time. So the other way to improve the average response time, it is by estimating the average response time. To express average response time in terms of these parameters, let us consider a system in which there are NA periodic jobs. The jobs in each periodic task have the same inter-arrival time and execution time distributions and the same response time requirements. Suppose that the average rate of arrival of periodic jobs in the ith periodic task is lambda I jobs per unit of time. The sum lambda of lambda I over all I is equal to 1 to A is the total number of periodic job arrivals per unit of time. The mean and the mean square values of the execution times of jobs in the ith periodic task are E of beta I and E of beta I square respectively. Let Ui denote the average utilization of the ith task. It is the average fraction of processor time required by all the jobs in the task. Ui is equal to lambda I into E of beta I. We call the sum capital UA of Ui over all periodic tasks the total average utilization of a periodic task. It is the average fraction of processor time required by all the periodic tasks in the system. Let capital U be the total utilization of all the periodic tasks. Then 1 minus U will be the fraction of time that is available for the execution of periodic jobs. We call it the periodic bandwidth. If the total average utilization of the periodic jobs is larger than or equal to the periodic bandwidth of the system, the length of the periodic job queue and the average response time will grow without bound. Hence, we consider here only the case where UA is less than 1 minus U. So this is the equation which shows the average response time, and the other thing in this equation, it is also defined like W0, it is defined like this. The first term in this equation W in the equation 5.4a, the first term gives the average amount of time required by an periodic job to complete execution if it does not wait for any periodic job. So that is the case where when it is not waiting for any other job, any other predecessor. The second term gives us the average queuing time, which is the average amount of time a job waits in the queue. So the second is the case where there is no predecessor in the queue of periodic jobs, and also where there is a case where there is a predecessor in the queue of periodic jobs, and also when the periodic job is waiting for completion of periodic job. We can improve the average response time of some aperiodic job tasks at the expense of some others by prioritizing the aperiodic tasks. Without loss of generality, suppose that we index the aperiodic tasks so that the smaller the index, the higher the priority. Instead of one FIFO queue, we put the jobs in each aperiodic task in a separate FIFO queue. The jobs in the queue of the ith periodic task are executed only when the queues of all the higher priority aperiodic tasks are empty. We let U, capital UH, denote the sum I minus 1 UK. It is the average total utilization of all aperiodic tasks with priority higher than the ith aperiodic task. The average response time WI of a job in the ith aperiodic task is given by the equation 5.5. This graph indicates the relation between the average queuing time and average utilization. So as the average utilization is increasing, it is high. When the average utilization it is high, the average queuing time it is very less. So they are inversely proportional. The average queuing time and the average utilization, they are inversely proportional. The next topic, scheduling sporadic jobs. So for scheduling sporadic jobs, and as these sporadic jobs they will have hard timing constraints. Even though they are similar to aperiodic jobs, they differ only in the case of timing constraints, where sporadic jobs they have hard timing constraints. So for scheduling sporadic jobs, that is even to take up their scheduling, their execution, we need to ensure that we are capable enough to end them by their deadline. So for that we will be using acceptance test before taking up a sporadic job. So what is an acceptance test? A common way to deal with this situation is to have the scheduler perform an acceptance test when each sporadic job is released. During an acceptance test, the scheduler checks whether the newly released sporadic job can be feasibly scheduled with all the jobs in the system at that time. Here, by a job in the system, we mean either a periodic job for which time has already been allocated in the pre-computed cycle schedule, or a sporadic job which has been scheduled but not yet completed. To illustrate that this approach is a reasonable one, we consider a quality control system. So here he explains the same thing, like what happens if a sporadic job is not scheduled by doing an acceptance test, by taking the example of any quality control system. A cyclic schedule or a cyclic executive. The stored table that gives the pre-computed cyclic schedule has F entries, where capital F is the number of frames per major cycle. Each entry lists the names of the job slices that are scheduled to execute in currently. In figure 5.7, the entry is denoted by L of K and is called a scheduling block or simply a block. The current block refers to the list of periodic job slices that are scheduled in the current.